Now that we have seen different types of guardrails, let's have a glimpse of how they are actually built in the real world. Let's talk about some of the popular techniques developers use to build these guardrails into AI. The most common one is the prompt engineering. This includes crafting the initial prompt, which includes the system prompt and the user messages to steer the model safety. For example, including instructions like "you are an assistant" that always refuses to give medical advice can act as a simple guardrail. We also use sometimes few short examples or spatial behaviors to shape the behavior of the AI model. Other than the prompt engineering, some other common techniques includes classifiers and filters. These are basically a pre-trained models or regex rules that detect toxic, illegal, or biased content in inputs and outputs. For example, the content moderation APIs, such as the OpenAI's moderation service or Azure AI content safety. Both of these categorize the inputs or outputs on the basis of hatred, violence, self-harm, jailbreak, and can block or flag disallowed content. These filters work hand in hand with LLM, vetting text before it's accepted or returned to the end user. Another novel approach that has been introduced by Anthropic is constitutional AI. It's a kind of internal guardrail in which AI learns to apply ethical rules autonomously. The model is trained with an explicit constitution of principles instead of relying solely on human labels. The model critiques and revises its own outputs according to the rules, like avoid toxic or illegal instructions. Anthropic has reported that this produced a model that was more helpful and more harmless than one trained only on human feedback. Another common technique that developers deploy is to fine-tune the model on curated dataset. For example, if you build on an open model, you might fine-tune it on a curated dataset, for example, on a bunch of many safe QA examples. So it learns to refuse dangerous requests. As a part of fine-tuning, there is another advanced approach known as the reinforcement learning using human feedback, which is also a model level guardrail, where human reviewers rank model outputs to train it to prefer safe answers. OpenAI's GPT-4, for example, underwent RLHF so that it became safer and more aligned over a month of iterative feedback. The GPT-4 technical report notes that RLHF was key to reducing hallucination and bias in the final model. No matter which popular technique you choose to design and implement your guardrails, it is crucial to keep in mind some of the best practices and key consideration whenever designing and implementing guardrails for the real-world applications. The first and the foremost of this is to watch for bias and fairness. AI can perpetuate societal biases. Use guardrails to block overly biased content, but also monitor model predictions for disparate impact on protected groups. Remember, as Microsoft's Fair Lunch creators note, you can't completely eliminate bias. Like, it's not possible that you can completely eliminate bias, but you must always try to mitigate fairness-related harms as much as possible. Another important consideration is to use multi-layered guardrails because no single guardrail is enough. McKinsey advises combining AI guardrails with other controls, for example, monitoring tools, governance frameworks, and human oversight. Microsoft similarly promote a layered defense that has a combination of filters, identity managers, monitoring to catch up any slip through. In practice, this means every request can be checked at multiple points: the system prompt, the model's training, input filters, output validators, and post-run monitoring all work together. Another important point to consider while designing guardrails for the real-world application is to choose an optimal threshold to calibrate the sensitivity. For example, the OpenAI cookbook note that tighter thresholds reduces false negatives but increases false positives. In high-risk domains like medical advice, it's often preferred to be on a stricter side. That basically includes refusing borderline answers. In lower risk cases, you might accept a bit more flexibility. Therefore, it is very important to choose an optimal threshold for your guardrails depending upon your use case. Regularly evaluate these thresholds with real data. If too many benign queries are blocked, loosen up. If harmful content gets through, tighten the filter. Another important and underrated consideration to keep in mind is to always have a human review loop. In practice, this means any content that triggers a guardrail should be logged and possibly reviewed by a human moderator or subject matter expert. In areas like healthcare or finance, treat AI as an assistant, not an oracle. Finally, you should always design for trust. Be transparent with users about what the AI can and cannot do. Log conversations responsibly, though respecting privacy, and allow user feedback to improve the system. Guardrails are not just technical, they are communicative. Therefore, it is important to build trust that the AI is acting deliberately and not failing silently. For example, whenever the AI refuses a request because of the guardrail trigger, it should provide a safe completion response, something like, I'm sorry, I can't assist with that. These were some of the best practices and considerations that you can keep in mind while developing and designing guardrails for the real world application.